Hi, my name is Georgios Tsimpiskakis, and I will present our research with title Phase versus Segment Comparison, a new method for comparing as-planned and as-built models. We focus here on SCAN-vs-BIM methodology, which is an innovative construction progress monitoring methodology that compares the as-planned and as-built model of a building under construction and identifies deviation and errors during the construction. So the problem with this methodology is that the current SCAN-vs-BIM application struggling to identify errors between the two models and report and visualize efficiently these errors. For example, one application that does not incorporate metadata in the results, and one other application visualize only the results on a heat map. So, to fill this gap, we proposed a new comparison method called phase versus segment comparison, which is included in the general improved SCAN-vs-BIM methodology, which consists of data acquisition, data preprocessing, phase versus segment comparison, reporting, then doing the necessary corrective actions, and then updating the initial as-planned model. However, we focus on this part, phase versus segment and reporting, mostly. We start with data acquisition. We acquired our as-planned model, actually the BIM model in IFC form, of a building that is under construction. Then we capture the as-built model of the same building environment during a certain time in construction in a point cloud model. Then we proceed to data pre-processing. We matching the point cloud model with the IFC model with several transformation process in order to make them ready for the comparison step. Then we move to point cloud model segmentation. We first apply a Randstad segmentation algorithm, but this algorithm does not provide efficient results, as we want every building element surface to be presented by a separate segment. And here segment 4 represents two building element surfaces. So we proposed a new segmentation process, Randstad DB scan, that first we apply a Randstad, and then on those Randstad segments we apply DB scan segmentation algorithm. So, and we see that the results are more sufficient, as almost every building element surface is represented efficiently by a segment. Then we move to phase versus segment comparison. Here we have phases and segments. A phase represents a building element surface in the BIM model, and a segment represents a building element surface in the point cloud model. So we make the comparison in a surface level, which is the innovative part of this comparison method. The phase versus segment comparison consists of two steps: matching phase with a segment and compare a phase with its matching segment. In the first step, the goal is to match each phase with a segment so that both represent the same building element surface in reality. So phase 1 from the BIM model should be matched with segment 1 from point cloud model, and phase 2 should be matched with segment 2 from the point cloud model. To govern this process, we formulate conditions and rules. There are many conditions and many rules that we have formulated, but we'll see only one now. Let's say we have this hypothetical scenario where of a BIM model and point cloud model deviating in the field like this, and we want to match this phase with one of these segments. So initially we have 8 possible match segments for this phase, so that to identify its matching segment, we establish a maximal orbital distance that a segment can deviate for a phase, which is dy phase divided by 2. And we say in condition 1 that the distance between the center of mass or the center of mass of a segment and the phase should be less than this maximal orbital distance for a segment to remain in the possible matching segment group. So after we have applied this condition, we have managed to reduce our possible matching segments into 4 for this whole phase. So by applying all the conditions, finally we have 3 possible cases for a phase. If no matching segment, the phase is labeled as missing. If one matching segment, the phase is labeled as existing, and if 2 matching segments, the phase is labeled as existing again, and then we have to apply rules to distinguish between these 2 segments. In rules, we have many rules, but here is one example. For example, we have a BIM model, point cloud model again deviating like this, and we need to find the matching segment for this phase. So we say that we construct these inequalities, and we say that the location values of both segment 1 and segment 2 along axis y are greater than the location values of both phase 1 and phase 2. So if this is the case, then if phase 1 location value is greater than phase 2 location value, then segment 1 matches with phase 1. Otherwise, segment 2 matches with phase 1. Then, after we have matched each phase with a segment, for the existing phases, we want to compare the phase with the segment. Then let's have this hypothetical scenario where the red segment matches with the yellow phase. We establish 5 deviations for each phase, 1 regarding phase location and 4 regarding the 4 edges of the phase, y min, y max, z min, and z max. And we say that we establish a maximum tolerance of 5 centimeters, and we say that if at least 1 deviation exceeds that tolerance, the phase is labeled as incorrect and is colorized red later in the results visualization. We test this with test data, and as we can see here, this is the point cloud model. Behind is the BIM model. We have some deviation here, which is 7 centimeters, and that's why it colorized red. This wall is colorized red in visualization. We report our results in table format. We report the results for every phase that we have in our BIM model. And we managed to report the IFC building element in which the phase belongs by reporting the IFC type, the global ID, the tag, and so that we want to know. So with this way, now we know more characteristics about the phases. Also, we report the 5 deviations for each phase, and we report also a state which is included correct, incorrect, or missing. We visualize our results in an OBJ file. The green phases are the existing and correct phases. The red phases are the missing or incorrect phases, and yellow phases are the excluded phases. One more important part here is that we also report the direction of the deviation with a sign minus or plus. Actually, for example, this means that for this phase, this edge, x max, deviates minus 1.5 centimeters towards this direction, minus axis. So with this way, we know more information about the deviations during construction. So with this method, phase versus segment, we managed to offer substantial advances such as customized deviation reporting, including in metadata, customized visualization, reporting 5 types of deviations, and identification of deviations direction, as I said. But we have some disadvantages, as this method is semi-automated. It needs user intervention, user inputs in the algorithm, and it's time-consuming. I forgot to say that we developed a Python algorithm to run this research. But with future research, phase versus segment comparison can facilitate the end user to quickly detect mistakes that are difficult to detect with the naked eye during construction, identify the nature of the mistake, such as, for example, if it's a missing element from the construction site, if it's extensive shifting, or if there are changes in the element's dimensions. And this can contribute to construction progress monitoring workflow by reducing the time required for construction progress monitoring and enhances the decision-making process. Thank you very much.